to the next type. Okay, so please open your book to page 92. Okay, when you got there, please raise your hand. Okay, when you have the page. Okay, so last time we just mentioned about the first type, right? It's compound interest. That's one of the exponential application, right? And the other type is called exponential growth and decay. So growth and decay, anything that grow, right, getting more and more, or getting less, you can use this formula. Okay, so we will start by making a table just like last time, and then try to derive a formula for the growth and decay. Okay, so can I have Eric, could you read the question on the top?
An endangered species of bear has a population of 10,000. Biologists estimate that the population is decreasing at 5% per year.
Okay, very good. So let's circle some important words. Okay, so initially there are 10,000, right? So this one is the initial population. You can write it down, initial, right? And then each year is getting less by 5%. So you can circle decreasing at 5%. Per year is also important. Okay, so these two. So just like last time, right? We have the year, right? The zero, and then number of time. Before was talking about interest, right? And total amount of money. This time, right? This one here is also similar. Okay, so at the beginning 0 years, so it hasn't decreased yet, right? So the number of times will be 0, and amount of bears will be 0, right? Amount of bear at 0 year will be 10,000. Okay, we started with 10,000. So after 1 year, because it says per year, it happens per year. So 1 year it only decreased once. So how do we find out how many bears left after 1 year? Irae, what do you think? How do we calculate number of bears left?
10,000 times 1.05.
10,000 times 1.05. That will make it.
Not 1. Times 0.95.
How did you get 0.95?
By doing math.
Doing what? Where's that number come from?
Because I subtracted 5% from 100%.
Yeah, okay, very good. Okay, so let me do it a little bit differently. Okay, so I will start with 10,000, right? And then I want to make it decrease. It decreases by 5%. So it'll be 0.05 of the 10,000. Okay, and then if we factor out, just like we did before, factor out the 10,000, then you would have 10,000, 1 minus 0.05. So the 0.95 that Irae said came from 1 minus. Okay, 1 minus 0.05. 1 is like 100%, meaning it has no change. And then 5% is the amount of change, right? So we can write it down as 10,000 times 0.95. Okay, and then just like compound interest, the number of bears will continue decrease for the next year, but it will decrease from the amount after 1 year. So you don't decrease from 10,000 anymore. Okay, so 2 years later, it will be decreasing 2 times. So we will be taking the amount that you had before, do the same thing. Okay, so amount at the beginning after 1 year minus 0.05 times amount after 1 year. Does anyone have questions so far? Okay, so what do you think we should do now? What's next step then? Cindy?
A1 bracket 1 minus 0.05.
Yeah, very good. Okay, so we will do the same thing. We factor out, just like before, we factor out 10,000. Here we factor out the A1, right? And then A1 represented by our highlighted is this one, right? 10,000 are yellow highlighted, right? 10,000 times 0.95 is A1. So I will replace that with A1 down there, okay? So if I do that, it will become 10,000 times 0.95, which is the A1, right? Multiplied by 1 minus 0.05, that's also 0.95, which will give us 10,000 times 0.95 squared. Okay, so as you can see here now, if it's 1 year, you will need to multiply by 0.95 to the 1, right? 2 years, it will be squared. So that's why it belongs to exponential function, right? We use the exponent to find what happens to the number of bears at different years, okay? So if it's t years later, this will be t, right? T number of time decreased. So what will be the formula then? Tiana?
10,000 bracket 0.95 to the power of t.
Yeah, okay, very good. So this one is a simple example first, okay? We'll start with this one. There are some variation later, okay? So let's use this formula. Take out your calculator. Let's do this question on the side, okay? So at this rate, what is the population after 8.75? And also it's asking what's the percentage compared to the initial, is that, okay? So I'll let you calculate that. And when you get an answer, please raise your hand. Okay, so Cindy, can you tell me how to set it up? Okay, not the final answer, but how to write it out.
10,000 bracket 0.95 bracket to the power of 8.75.
Yeah, okay. And remember at the front, please write down A of 8.75. Okay. Let's move this. Okay, please raise your hand if you get an answer. Okay, let's check the answer now. Okay, Ray, what do you have?
6383.83.
6383.83.
Yeah.
Okay, and this will be number of bears, right? So we got to do some rounding. Okay, Donna, how about you? What do you have?
The number of bears
Yeah, is it the
with
same number?
was rounded.
Yeah.
6383.
Yeah, okay, so you won't round it up, okay, because you cannot have 0.83 number of bears, right? So about 6383 bears. Okay, so there's a second part to the question, right? First part is asking how many bears. Second part is asking what's the percentage of the initial amount. How do we do that? Have you found that? Eric, did you get a percentage?
Yeah,
Okay, how do you do that?
you divide your answer for part 1 by 10,000.
Yeah, okay, so compare with the original. Over 10,000, but then that will be a decimal, so you got to multiply by 100, turn it into a percent. Okay, so what's the percentage then? Donna, what do you have?
63.83%.
Yeah. Okay, so remember, if sometimes they ask for number of bears, sometimes they ask for percentage. Okay, make sure you don't answer the wrong thing, right? So got to read the question carefully. Okay, so let's look at a question similar. Okay, this one is, let me see, which one should we do? What's the, okay. Number 8, okay, let's do question number 8. I'll let you try this, okay, pretty straightforward here. This is about the price of a house, okay? So part A is you don't need to calculate anything, right? You just write out the formula, okay? Set it up, subbing the value into the formula. And then part 2, part B, is to use what you get in part A to answer the question. Okay, so it shouldn't be too complicated. Let you try this. And please raise your hand when you finished. You can also raise your hand if you feel you get stuck, okay? And then don't know what to do. So we don't have to wait for too long, okay? So just make sure you guys all tried it, and then we'll go over it. Okay, let's double check the formula first, okay? The function, exponential function, because this one is a bit different, right? Is instead of decreasing, is increasing by 12%, okay? So let's see if you know how to set this up. Cindy, what do you have for your formula?
355,000 bracket 1 plus 0.12 to the power of t.
Yep, very good, okay? So if it's decreasing, then you subtract from 1, right? Increasing, then you add it to 1. Just remember the 1 is 100%, right? So meaning no change, right? So you want to make it increase, and it's better that you add it up, okay? So just write it as 1.12 to the t, okay? Next part, we want to find the value after 10 years. So obviously it will be a of 10, okay? Let's just check the answers. Tiana, what answer do you have? 10 years.
1102576.1.
76.10.
11.
Oh, 11. Okay. Because it's money, so we need to know the cents, right? So let's check. Eric, do you have the same?
Yeah.
Okay, Ray, how about you?
Yeah.
Okay, perfect. Okay, so that's a big difference, right? Yeah, so if it's a 12% increasing, you can actually make a lot of money, right? Just by buying the property, rent it out, right? And then after 10 years, okay, you got a lot more. Okay, so let's look at the next table, okay? So this is, you can apply the formula with increasing or decreasing. Now, for this table here, there is a little bit difference, okay, compared to other one, okay? So this bacterium is also increasing, but it's increasing instead of by percentage, right? It tells you that it's doubling. So what will be the percentage if you are doubling? Donna? If you want to double something, what's the percentage that represents double? Donna? You there? Is your mic working? Okay, I guess her mic is not working again. Okay, let's try Eric. What do you think? Double, what's the percentage?
200%.
Yeah, 200%. Very good. Okay, if it's 100%, no change, right? So 200% will be like times it by 2. Okay, so you can write it on the side. So instead of saying 200%, they say double. Okay, it's the same thing. Now the new thing is this part. Every 7 days now. Okay, so there's a pattern here. So what's difference from before? Right, we have decreasing per year, right? So that's once a year. This one is also each year, right, for the house. So there's no special kinds of period, right? But then for this one is saying every 7 days, right? It's not every year. So the way we find this will be different, okay? And the unit's different as well, right? Instead of years, we have days. So let's look at the table, okay, to find a formula for this one. Okay, so for example, we'll start with 0, right? 0 means beginning, right? So at the beginning, the number of times doubling happened. Okay. So just like before, right? At the beginning, there's nothing happened yet, right? And then the number of bacterium at the beginning is just 1. Okay, because it says a bacterium, right? Means 1, right? 1 bacterium. And then because it doubles every 7 days, so we have to go by multiple of 7 here, right? So 7 days later, right, it will double once, right? Because it takes 7 days to double. And then the amount of after 7 days, you take what you had before, right? 1, and you double it, right? So 1 bacterium becomes 2 bacteria. Okay. Now another 7 day, another week has passed. It doubled again, right? And then you continue from what you had before, right? So you have to take A7, right? Whatever you had before, and then double that, right? So just like before, we got to replace, right? A7 is actually this whole thing. So we would have 1 times 2, which is the amount after the first 7 days, and then double that, right? Let's express this using exponents. So you will have initial is 1 multiplied by 2 means double, right? To the square. Okay, so if it's 7 days, it will multiply by 1 to the 1 times 2 to the 1, right? 7 days, it will be 1. 14 days, it will be 2. Okay? So that's kind of the pattern, right? So if it's 21 days, another week, 21 days, it will be to the cube, right? So what about t days? What will be the number of times, right? What should we fill inside here then?
T over 7.
T over 7, very good. Okay, we need to see how many 7 fits inside the total time, right? Then what about the formula then? What's the function? Anybody? What's the function to write out?
1 times 2 exponent.
1 times 2, and then
Exponent over 7.
exponent is t, right? T over 7. Okay, so if it's t days, then exponent is t over 7. So depending on the question, right? It's not always 7. Okay. If it's every 2 days, then you have to do t over 2. Every 4 days, t over 4. Okay. So the formula will be this one for this question, right? Let's use this to answer the question on the right. So after how long will a single bacterium grow to this amount? Okay, so of course that's a big amount. Okay, we are looking for how long, right? Instead of finding how many bacteria, we're looking for how long it takes. Right, so I'll let you try this by yourself first. Think about where do we plug in this 8 to the 30, all right? I'm going to just copy the formula again, okay? And then let you guys try it first. If you get an answer or you have no idea how to do it or you get stuck somewhere, okay? Doesn't matter, then you raise your hand, okay? So your final answer should be how many days, right? Because we're looking for how long it takes. So your answer is number of days. Let me highlight some of the things here, okay? A of t, the initial, the double, right? And the t and the 7, okay? We have 1, 2, 3, 4, 5, right? 5 items in this formula. So I would like to know, where do you plug in 8 to the 30? Cindy, what do you think? Where should we plug in the 8 to the 30?
80.
80, very good. Okay. So 8 to the 30. So that you will be looking for time, okay? If you have an answer, please raise your hand. Or if you get stuck, okay, also raise your hand. Okay, Ray, what's your answer? How many days?
630.
Okay, 630 days. Tiana, how about you?
I'm not sure.
Do you have different answer?
No.
Okay, did you get stuck anywhere?
Yeah.
Okay, did you have this line right now?
Yes.
Okay, so right now our goal is to isolate T, right? Yeah,
Mm-hmm.
okay, so this has to do with what we learned last week. Okay, last week we learned a method called same base. Remember that? Yeah?
Yeah.
Okay, so that's for solving exponential equation that has exponents. Okay, so that's what we are going to do. That's why we learned that last week, right? So we can apply over here. So we'll slowly isolate T. Okay, so first thing, what do you think we can do first? What do you think the same base is? What's a same base?
2.
2, right? Has to do with 2. So 2 to something equal to 2 to something. We need to make it look like that first, right? Eventually, right? So what do you think we should do first?
2 to the 3 to the power 30.
Okay, yeah, so we can write it like that. Very good. How about right-hand side? What should we do with the 1?
Put it over
Over where?
left
And how do we put it to the left side?
-1
Well, what's between the 1 and the 2?
times
Times it, right? So if you want to get rid of the multiplying, you need to
divide.
divide, okay? So you can divide both sides by 1, okay? But if you divide by 1, it doesn't really do anything, right? Anything divided by 1 is still the same. So right-hand side will just be 2 to the t over 7. Make sense?
Yes.
Yeah, okay. And then Eric, what about you? Did you get an answer?
Yeah, I got 630 as well.
Okay, so can you tell us what to do now, next?
Multiply the 3 and the 30.
Okay, so that makes it 90 and t over 7. Now what?
You can take out the 2.
Yeah, so drop the base, 90 equal t over 7. And finally,
You multiply both sides by 7.
yeah, okay. So, or you can do cross multiply, right? And then that will give us t equals 630 days, okay? Don't forget to write the units. So the units, to determine the units, you look at the denominator, okay? This part, the 7 and the time, okay? They should both have the same units, okay? If they say it takes like 7 hours, then the answer you will also be hours. It will be 630 hours, okay? So they should have the same units. Okay, does anyone have question about this example? Okay, so from this example, we can write out a formula now. Okay, so let's go back to the last page on the top right. So the formula we will have is A of t. So it could be number of bacteria, number of bears, right? And then A of 0, so that's your initial amount. And then you have the growth and decay, right? So sometimes it's 0.95, right? 0.95 if it's decreasing by some percent. Sometimes it's 1.12, right? So if it's increasing by 12%, sometimes even 200%, right? The 2, double, right? Triple will be 300% of 3, right? So all of those, I just called it the rate. So you got to figure out the rate by yourself, okay, based on each question. Right? You got to read the question. Is it using the 1 plus, 1 minus, right? Or just double, triple, half, right? Could be half. Each time it gets less by half, okay? And then you have the T over P, okay? P is called the period, like how long it takes for it to change, right? For example, for it to increase, for it to decrease, for it to double, right? For it to get halved, right? The period, the amount of time, okay? So we need to write down what each one means. Let's put it over here, okay? So this one is the final amount. Okay, so it's not A times T, it's A of T, it's one single thing, right? And then next one here is the initial amount. Okay, and then the middle one, the rate, is it could be, if it's an increase, by some percent, then you use 1 plus the percent, right? If it's decrease by some percent, you will use 1 minus the percent. All right? And then if it's like double, use 2. If it's half, you use half. Right? Pretty straightforward, right? Quarter, you put a quarter. Triple, you put a 3. Okay, etc. Okay? So it could be in percentage, could be integers, right? Could be fraction too. And then finally we have the P. Right? P is called the period, or we call that the life period. Okay, let's put the life period, the meaning on the side here. Okay, so because that one is more important. Okay, a little bit more confusing than compared to other ones. So life period means the time it takes to or for the amount, okay, let's change that. The time it takes for the amount to change. Okay. Is there any part that you have questions here about the formula? Okay, just like compound interest, you have to know what each part represent, right? So when you read the question, you know what number to plug in. Okay, so these are two very important formula. The second one here, anything that gets bigger, more, anything gets less or decay, right? You use this formula. All right. So if you finish copying the formula, please raise your hand. Samantha, are you done? Okay. So we are going to try a few more, okay, question using this formula. So of course, I didn't mention the T, right? T is the total number of time, right? How long it takes for initial become final, right? The time from initial to final, okay? You can fill that out, but I think T should be pretty easy to understand, right? The total time you let it grow, okay, or decay. All right, so as you can see here, just like the example we had before, there's always 5 blinks, 1, 2, 3, 4, 5. So when you get a question like this, you always draw the 5 blanks first. And then inside the 5 blanks, there's always one missing. Right? In this example, we had the T number 4, right? The 4th blank is missing. So that you have a target, right? You know what do you want to find, okay? So make sure you put the number into the right places. Okay, so let's try that out. Look at number 10. Okay, so you can begin by drawing the 5 blanks. All right, so once you filled in everything in the blanks, okay, you don't need to solve it yet. Okay, just put it in and you can raise your hand. Okay, we'll check if you get the right thing in the blanks. If you put the wrong number in the wrong place, right, then there's no point moving on, right? You got to make sure your initial step is correct. So think about which number goes where, right? We have the 12, we have the 2, we have the 768. So 5 blanks should be only one missing. Okay, if you feel that you already filled everything, right? Filled everything in, or you don't know some of them, you can also raise your hand, okay? Just fill in as much as you can, as many as you can. Okay, let's check one of your answer. Okay, I will get a few of them, of your answers. Okay, so Donna, how did you fill in the blanks?
600, no, 768.
768, and then
12,
sorry, I can't hear you.
12,
12. Okay,
2,
2, and then
2 repeat.
2 over p, like that.
I don't know.
Is it? Yeah, okay. How about Cindy? We go
Seven,
order, okay? 1, 2, 3, 4, 5, okay?
768
Okay, and then
equals 12
and then
to
and then
t over 2.
p over 2. Okay. Let's see if anyone get different things here. Okay. Does anyone have different? E-Ray, what do you have?
I have 12. That's it.
You have 12. Where does the 12 go?
Next to the equal sign.
So number 1, 2, 3, 4, 5,
2.
2. Okay, so 12. Nothing else? Yeah.
Nope.
Okay. Eric, how about you?
I have the same as the first one.
Same as the first one. Okay, let's go over it. Okay. So make sure you look at the formula, right? Understand what each blank is for, right? That's how you do this kind of questions, all right? Only you know what they mean, right? Then you can find the right number. So let me draw it out, okay? So it says it starts, right? Starts means initial, right? That's pretty clear. So I think everybody has no question about that, right? Initial, there are 12. So of course, number 12 goes there. After 2 hours, it becomes, right? The count, we count the bacteria again, becomes 768. So it takes 2 hours to go from 12 to 768. So 768 is like your final, right? And it takes 2 hours to go from initial, right, to final. So the 768 should go to here, the first blank, because first blank is for final. And then the 2 hour, it should go to the top, the T. Okay, because remember I said over here, the last one, right? If you want, you can fill this in, okay? T is the time it takes from initial to final, okay? If you're afraid that you will forget what it means, right? The time it takes to go from initial to final, okay? You can write that down. So it has to be the 2, okay? And then it's looking for, right, what? What means it's looking for, right? What is the doubling period? So it's looking for the period, right? That's a keyword. So that's why P is missing. What is the period? And double is just telling you that the bacteria will be always doubling, right? The time it takes to double, that's called doubling period. So that's why the rate you'll be writing as 2, okay? So T will also be 2. They're both 2, but different meaning, right? So 2 hours to go from 12 to 768. And every time the bacteria will be doubling, and we want to find out what's the period for it to double every time, right? How long it takes to double each time. Okay, any questions? So you got to break it down, right? Every question you got to think thoroughly, right? What it actually means. So there are some keywords like period, right? Doubling life, right? Sometimes they say double life, okay? It means the same thing. You can write it on the side, okay? Doubling period, doubling life, okay? It's the same as the P, okay? So this is the P. All right, so now we got the formula set up. Please solve for P now, okay? So I'll let you do this by yourself now. And when you get an answer, please raise your hand, okay? Or if you get stuck, okay? Also raise your hand. If you forgot how to solve this, right, take a look at what we did before. And remember to write out the units, okay, when you find the answer for the period. Think about what units we should use. For the final answer, just write out the simple sentence. Doubling period is something, okay? So Cindy, what do you have? What's your doubling period?
12.
12 what? 12?
Hours.
12 hours. Okay, so every 12 hours it will be doubling, right? So that's what it means. Let's check. Tiana, what do you have?
I have 1/3 hour.
1/3 hour. So every 1/3 hour. So 1/3 hour is like how many minutes? Each hour has
20.
yeah,
20.
yeah, 20 minutes, right? Each hour is 60 minutes. A third of it, right, is 20 minutes. So every 20 minutes, it will double, right? Every 20 minutes. Okay, let's see if we got something different. Eric, what do you have?
I also have 20 minutes.
20 minutes? Okay. Ire,
20 minutes.
20 minutes? Okay, let's go over the steps, okay? To see what step you took, all right? Cindy, what do you do first?
I divided 768 by 12.
Okay, very good. So both sides divide by 12. Can you tell me what you have on the left side?
64.
64, okay? And then right side will be 2 to the 2 over p, right? Is that what you got?
Yeah.
Yeah, okay. What's your next step then?
Change 64 to 2 to the power of 6.
2 to the 6, yeah, that sounds about right. Okay, and then 2 over p. And then
6 equals 2 over p.
so drop the base, and then
Oh, never mind.
yeah, what do you do now? What should you do?
Oh, p equals 1 over. Wait. Yeah, p equals 1 over 3.
Yeah, okay. So when you do the solving, right, because this time is p in the denominator, right? So if you do cross multiply, right, it will be 6p equal to 2, and then you solve for p, it will be 1/3. Okay, and 1/3, remember, is 1/3 hours, which will give you 20 minutes, right? You can answer in either way. They mean the same thing. Just make sure you show the proper units, okay? All right, so the next one, same thing, okay? I'll let you try this by yourself as well. If you get stuck or finished, okay, raise your hand. So I will just check until the final answer, okay? I'll let you try fill in everything by yourself. Just pretend this is like your homework, okay? And then see if you can get to the final answer. So this time is rabbit. Okay, does anyone have trouble filling the blanks?
Yeah.
Okay, so then you can raise your hand. Okay, if you get stuck already, you can raise your hand so I can go over. Otherwise, we'll be waiting till end of class. That's not good. Okay, so Tiana, did you fill in anything?
Yeah.
Okay, what do you have so far?
For the first one, I put 1 over 128.
Okay, let me number them first. Okay, 1, 2, 3, 4, 5. First one, you put 1 over 128. Yeah.
Yeah, and then the third one, I put it 1/2.
1/2. Okay. Yeah. Anything else?
And then for number 2, it's just A0 or A0.
Okay, A of 0. So initial amount. Yeah.
Yeah, that's it.
That's it. Okay. Can anyone else add it to that? How about Eric? Do you have the same or something more?
In 2, I have 128.
In 2, you have 128.
Yeah, and in T, I have 35.
T, you have 35. So up there. Yeah.
And the rest, I have the same too. So 1
Then
over 128.
1 over 128.
Yeah, and
1/2.
yeah.
And then we're looking for P. Yeah. Okay. How about Ray? How much do you have?
I have that.
Huh?
I have what we did up to now.
You mean the which one? The second line?
Yeah, second line.
Okay. So you have the same thing as the second line?
Yeah.
Yeah. Okay. So number one, the first line, what Tiana did is good as well, right? Second one is good as well. Just each of them has is different way to look at the question. Okay, so each one of them has a little mistake in there. Okay, so I'll go over both ways and then talk about how you can do each different way, right? So let's take a look, right? Because the difference from for this one from number question A is that it did not tell you how many to start with.
Wait, Jason, I have something different.
Okay, okay. What do you have?
I wrote 1 over 128
Yeah,
equals 1,
yeah.
and then 1 over 4,480.
1 over 4,480.
Yeah,
Okay,
the top is the same.
so 35 over P.
Yeah,
Okay, where did you get that number? 4480.
I did like 1 over 128 divided by 35.
Oh, divide by 35, like that?
Yeah,
Okay, I see. Okay, okay. We'll go over each one, all right? So each try here, okay, you all have your correct part, okay? So let's talk about the first one. The part that's missing for the first one is, well, since they did not tell you the initial, right? So it's actually a good idea to just fill in with A0, right? Because it didn't tell you. So that's saying that it doesn't really matter, right? It can start with anything, okay? So it's telling you a ratio here. In the question, it says that the rabbit will decrease to, right? Let's underline this part. Decrease to 1 over 128 of its original amount. But it did not tell you how many original, right? So if I want to make the first one correct, I just need to add A of 0 at the front. Okay, you started with A0, right? Initial. And then you finish, right? Final amount here. Final amount is 1 over 128 of means multiply, right? multiplied by a of 0. Okay, then your initial and final is all filled in. Okay, next part it tells you that it's half-life, right, or half period. When you see the life, see the period, that's telling you the rate. So this part you should use the half. Okay, which is going to correct this one, right? This one should be using half. The rate is saying how it's changing every time. So because it tells you that it's a half-life problem, right? So it's saying every time this whatever life we have here, this one is for rabbit, right? The rabbit is getting less by becoming half every time, okay? So use 1/2, okay? Because the rate is for every time, okay? And then, so let's change that. Okay, and then number 4, I think number 4 is the total time, right? After 35 years, it changes from initial, right? Initial to final, it takes 35. So that part, I think everybody is fine. And we're looking for the life, right? Life period. So that's P. Okay, so then this way is okay, right? Now the second way is also close. If you do something like this, if you want to start with 128, that's okay too. But then your final, it should be 1 over 128 of 128, because you started with 128, right? So your final amount should be what then? Eric? What's 1 over 128 of?
1.
Yeah, so it will become 1. Okay, if you put that there, put the 1 at the final, then it's okay. Then it will be correct. Okay, so depending on what you put at the beginning, right, as initial, then you do the same thing. Okay, so either way is all right. Yeah, so now all three, right? So like Cindy's way, right? She started with 1. That's okay too, right? She can start with any number. And then the final amount will be 1 over 128 of, so multiply with 1, right? And multiply by 1 is just the same as 1 over 128, right? So if you want to start with 4, then you will multiply by 4, okay? It doesn't matter because the question did not tell you what to start with, okay? So it's just a ratio. It only tells you the ratio between the two, okay? So I have to pick one way to do it, okay? I'm gonna pick the first one, okay? Because it did not tell you, so usually I will start by writing a unknown there, okay? So let's go over how to do it if there's an A0, okay? So I'll erase the rest, okay? But all three ways works, okay? So let me erase that, okay? So to solve this now, as you can compare with what we had before, right? Your very first step was to divide both sides by 12. So same thing here. We can divide both sides by A0. So you can see if we do that, the A of 0 actually doesn't matter anymore. It's gone. Okay? So it will end up as the same as Cindy's. Right? But that's the A of 0 was there, okay? It just canceled out. So after this, you do the same thing, try to make it same base, and so for P, all right? So I'll let you carry it out the rest, and when you get an answer, please raise your hand. Okay, Donna, what's the half-life?
5 years.
5 years? Is that what you said?
Yeah.
Yeah, okay. How about you, Ray?
Same.
Same. Cindy?
Same.
Same, okay. Tiana, how about you?
Same.
Okay, okay, sounds good. All right, so let me just quickly write out the steps here. So what's the same base that you guys chose? Eric?
2.
2, okay. Then left side will be 2 to what?
-7.
-7. Okay, so this will be 2 to the -35 over p. And then drop the base, right? So that will give us p equal to 5. Okay, so units should be in years because 35 is also in years. Okay, so let's take a early break today, okay? Because after this we'll be starting log, okay, which is a fresh new start, okay? So we'll have 15 minutes. I'll see you at 6:20, all right? If you have questions, you can stay after. Okay, see you soon.